am LYDIALLYE, the video director of this project. Hope you enjoy the video.
My name is MAIZURAH Binti SHAMSUDDIN. I would like to share about the future role of engineer towards the society development. As you can see in the history of engineer, like how they do in the past, the evolution of civil engineering also renewal the shift in technology and structure. For example, shift in structure are Kuala Lumpur from 1990 to 2016, how they make changes to the structure of the building according to the current situation and with new technology. For other example in structure, we can see Shanghai from 1990 to 2015, New York City from 1876 to 2013, and same goes to Dubai City from 1990 to 2015. The shift in structure occurs depending on the passage of increasingly advanced and modern times. We can see how from past to present structure to be built. Next is shift in technology that makes evolution in civil engineering, like how from 2D drawing design become 3D drawing design. Besides that, technology must be friendly used. The shift in technology at work site from H-frame form work from past change to climbing form work at present. This shows that new technologies evolve over time which suit the user of the new generation. Next is the main role of civil engineers is in surveying, planning, designing, estimation and execution of structure like buildings, road, bridge, railway, ports, airports, dam, canals, water and wastewater treatment plants. Civil engineer is the one who design and maintain the work of public utilities. The main role or duties of civil engineers are to use scientific and engineering principles for solution of different engineering problems. Next is to solve different engineering problems with the help of field experience, laboratory techniques, mathematical models, using computer and information technology. Last but not least, there are some of the roles of civil engineers, and I would like to share some quotes that can be related to civil engineering, which is engineering is the art of directing the great source of power in nature for the use and convincing of men by Thomas Treadgold.
This is the longest sea crossing bridge in the world. The preparation and construction took civil engineers 15 years to complete this huge structure. Used 500,000 tons of steel to build the longest steel bridge and took 2.3 million tons of reinforced concrete to build the world's longest submarine tunnel under the deep sea water. Civil engineers must do their utmost to resist the typhoon and earthquake, as well as to complete the building under strict environmental protection requirements. And it is the Hong Kong-Zhuhai-Macau Bridge. The Hong Kong-Zhuhai-Macau Bridge is a large cross-sea channel connecting to Hong Kong, Lantau Island, Macau and Guangdong-Zhuhai. The preliminary work of bridge started on August 2003. The construction started on December 15, 2009 and it completed on May 23, 2018. The design life is 120 years. It can withstand a magnitude 8 earthquake, a magnitude of 16 typhoon, an impact of 300,000 tons, and the once in 300 years flood tide at the Pearl River estuary. It is also called one of the 7 wonders of the modern world. The Hong Kong-Zhuhai-Macau Bridge is composed of 3 navigation bridges, an undersea tunnel, 4 artificial islands and connecting bridge and tunnel, a continuous beam bridge with non-navigation holes in deep and shallow water, as well as a land-connected line between Hong Kong, Zhuhai, and Macau. Among them, the three navigation bridges from east to west are the Qingzhou Channel Bridge, the River Sea Direct Ship Channel Bridge, and the Jiuzhou Channel Bridge. The submarine tunnel is located between Hong Kong's Lantau Islands and the Qingzhou Channel Bridge and connected to other bridge sections through the east-west artificial island. The non-navigation of continuous beam bridge in the waters area are respectively located in the water near Hong Kong and the water near the Pearl River. The three ports and their artificial islands are located near to approach bridge at the both ends, connected to the surrounding main road through connecting line. In response to stringent requirements such as low water resistance for cross-sea project, non-interference of water, land and air three-dimension transportation lines, environmental protection, and driving safety, civil engineers adopted a 3-in-1 building form of bridge, island, and tunnel. The whole section of the bridge is an S-shaped curve, and the axis direction of the bridge pier is roughly equal to the direction of water flow, which can not only relieve driver fatigue but also reduce the water blocking rate of the bridge piers and improve the aesthetic of the building. The bridge has brought a lot of room for development in Hong Kong. Furthermore, Zhuhai can also use Hong Kong's economic advantage to grow rapidly. Macau will also get more tourism resorts. Therefore, this shows that civil engineers play an indispensable role in natural development. They are not only improving the country's economy, and also brings the convenience to all society. As a civil engineer, you must possess extraordinary courage, self-confidence, creativity, and innovation to lead the country into a better future. In addition, all the effort of civil engineers is to fulfill the dream of mankind. Hence, we hope that everyone can better understand the responsibility of civil engineers and respect them.
Beijing National Stadium is the world's largest steel structure. This stadium was the Olympic Games' most striking structure, which recognized all over the world during year 2008. The building's dynamic form and vast scale create a new icon for China and the city of Beijing. The circular shape of stadium represents heaven. The structural form of the stadium is popularly described as a bird nest, with its pattern inspired by a Chinese-style craze pottery. It called bird nest because of the lattice-like design and its intricate design. The stadium was built during year 2003 and completed in year 2008 for Olympic Games and can seat up to 1 million people. The stadium is not just a remarkable piece of architecture and structural engineering, but it also sets a global standard for spectator experience. It was designed around people for ensuring an optimum view, comfortable seats, and maximum enjoyment for sporting events. The stadium, made out of two independent frames which sets 50 feet apart, an inner concreted bowl for seating and an outer steel frame making 42,000 tons. The stadium consists the effects of thermal expansion, that is, the tendency for steel to expand and contract when the temperature changes. It also energy efficient and environmentally friendly because it has a geothermal pump system to collect ground source energy to keep the stadium cool in summer and warm in winter. As China is surrounded by some of the deadliest fault lines, so the stadium has to be earthquake-proof. Dividing the concrete building structure of Beijing National Stadium into 6 parts was the key to safety. Being isolated, each part could move flexibly and independently in earthquake so that it would absorb the energy by its free movement instead of being broken into pieces by this energy. Then it was to be surrounded by metal bolt If the concrete accidentally falls, the steel would be unaffected and would support the structure frame. Therefore, the stadium are able to withstand an 8.0 magnitude since the steel roof is separated from the sitting bowl to ensure the render of the structure of the earthquake resistance.
Engineering is a very popular career field in our society. Engineers apply science and technology in solving a problem in the field of work. This professional field requires quick and accurate thinking skills in making a decision. The responsibilities of being an engineer are also huge because they play an important role in a project. The topic I will be discussed today is what civil engineer need to do in the future and why it is important. There are some points that I will be discussed which are related more on the nature of work on the construction site and the situation that will often occur while on the site. The first point is new graduate engineer need to be sensitive and trained with software or the critical path method CPM application. This is because construction work is more vulnerable and often use CPM for planning. Budget cost, machine, entry and exit, work involving management work with local authorities, for example, GKR, GPS, and JPA. In addition, undergraduate engineer should also be exposed to management or local authority. This is because before construction work is done on site, it is necessary to get approval of the local authority. For example, electric poles consisting of HV or high voltage require CNB or RCSB shifting, either for temporary location or a retained location. For the transfer, the engineer needs a plan, approval and a letter of authorizations from SSB or TNB. Civil engineer also need to be sensitive to the guidelines used from time to time. For example, construction work and work road issued by GKR. Lack of sensitivity to the guideline will allow the work to be terminated immediately and the contractor may be subject to action. Civil engineer in the future need to be exposed to electrical, mechanical, ICT, and fire hose drill scope. This makes it easy for civil engineer to monitor the work done, especially before the test and commissioning (TNC), certificate of practical completion (CPC), and occupancy certificate (OC). In the future, increasingly sophisticated technology will be more challenging for a civil engineer. For a 200-meter road project, an engineer can monitor the progress of road construction using only a drone. Therefore, an engineer in the future need to be sensitive to the sophistication of technology. It includes with the use of system, for example, the BMS system, where the building management can be controlled for maintenance work. For example, in the civil divisions, which consists of sewage treatment plants, STP, can be controlled in the event of a trip or it operates manually.
Civil engineer can be concerned the use of the nanotechnology in the future towards the society development. This is due to their submicroscopic size and they have a unique material characteristic. This can improve the society development in the future by using the technology. Nanotechnology involves the study of materials that are range below 100 nanometers in size. It is a field that has emerged in the past decades and has many applications in a wide range of the fields including civil engineering. Nanotechnology mainly used to give a stronger structural composite, lighter structure, low maintenance coating, reduce the thermal transfer rates of fire retardant and insulations and others. First, nano coating for concrete. In order to protect the structures from abrasion and chemical attack, the chemical coatings are generally and routinely used. The use of nanotechnology to limit the size of the coating materials in micrometer range can make a great advancement. The types of nanoparticles in various binders and their effectiveness on key properties related to the concrete's deterioration have been studied. It has been reported that a solvent that containing a low molecular weight epoxy resin and nanoclay particles has shown the promising results. In addition, nanometer thick coatings are durable and have self-cleaning and self-healing properties. Nanoscale roughness of the coatings has the property of repelling water and dirt and can outdate the existing non-stick technology. Self-cleaning properties of coating made of nanoparticles will also help to keep the coating surface totally free of dust. And in the construction industry alone, venture capitalists and corporations have invested in the concrete and steel for the use of constructing buildings. For instance, incorporating nanosilica, nanoclays, or nano-iron particles in the concrete. This can improve the pore structure of the concrete as well as combat the problem of low strength at the early stages. Meanwhile, in the production of steel beams, the surface of the finished product can be added of copper nanoparticles. By doing this, the overall stress and fatigue of the structure will be reduced. In addition, using the nanoparticles for the fire protection, the application of the Portland cement-based coatings in the fire protection of the steel structures is limited because it is thick. It also tends to be brittle. Then a solution come up with adding the polymers to improve the adhesion with the steel surface. It has been found that nano cement mixing with the carbon nanotubes with cementitious materials to fabricate the fibro composites has outstanding properties of high strength and fire resistance. In short, nanotechnology has the potential to be the key to a new world in the future towards society's development. Furthermore, nanotechnology is rapidly expanding field. It has the potential to change the service life and life cycle costs of the construction infrastructure, thereby creating a new world in the future.